Thanks, Matt.
Sure.
Appreciate it. And yeah, it's such a small group, which understandable. We went over on the keynote. Feel free to just interrupt. We can make this more interactive. In fact, I'd love to kick it off before I go into the specifics. Love to poll the room. Who's on-prem today? Not really in the public cloud at all. Okay, reasonable chunk. What about folks as far as big cloud, AWS users? How about Google Cloud users? Microsoft Azure users? Okay, interesting. Of course, our goal is to see it balance out over time. So, well, we have some work to do on that front. So I'm here to talk about global clusters. I stole all my own thunder in that demo earlier. You all probably saw it. So yeah, unfortunately, it's not going to be as fun to really unveil anything here. But let's talk about what this is fundamentally all about. This is the number of people, 3.15 billion, who have become online, internet citizens since MongoDB's first code commit, which was something like 11 years ago now. So it's a mind-boggling figure. It's truly global. Matt mentioned I did indeed live in South Asia for a long time, and the kinds of places where SMS, marketplaces exist, and all of those people now, a couple years later, have smartphones. It's really happening. So truly 4 billion online globally. This is an old slide from 2011, so it's only grown since then. But we can see the population on the internet and the percentage of the population that was on, and that's from 2011. So I think most of us here, we mostly think about Europe, we think about the US, and global clusters are certainly pretty cool for reaching those regions, and they make it really easy to have a cluster that spans just Europe and the US. But I think all of us need to start getting ahead of the curve and thinking about our business is going to shift to be truly global. And it's not just going to be the US or US East, those shortcuts that we traditionally use. Let's be honest, most of us have our cluster in US East, and that's it. But it's changing. And it's going to be easy to take advantage of this change, luckily. And the opportunities of this change with a global customer base are immense. Indeed, every year, nearly US-sized population is coming online for the first time every year. Obviously, the purchasing power is not there yet, but it's going to change. Opportunities, the winners in the space who reach and deliver applications to this global user base are going to kill it, basically. I already used this line, but traditionally, only the Facebooks and Googles of the world have really been able to reach that global user base in a true operational sense. And that doesn't need to be the case anymore. Now, I think we've often thought of CDNs as the way we can reach the global audience. And essentially you can. You have cache readable data that is available at low latency for all these folks. And that has gotten us this far. I mean, it's a huge advantage, kind of a shortcut though. But fundamentally, users expect more. It's not enough to just see data that's been cached from somewhere else at low latency. That's extremely restrictive. They want low latency writes, interactive data. They want updates, interactions. They want instant gratification. That's really what it boils down to, everywhere. We're used to this. We have instant gratification because the apps are built for us since we're in US East right now. But a lot of the users in the world have a terrible experience. And we don't have to keep that the case anymore. Obviously, we use MongoDB so we can deliver relentless improvement. That's what the users also want. We want to stay focused on building those applications that we heard about this morning. They want personalization. They want things that are built for them, not something that's centrally deployed through a CDN for everyone and it's kind of watered down for any individual, et cetera. You want them to be happy with all those things above because that's how you make money. Or get just more users, which whether or not you're in it for the money, you want to build a global presence, it's awesome to do so. You, like all of us, like ourselves, are under immense competitive pressures, and you need to stay ahead. You need to go after the biggest opportunities before they're, frankly, popping their heads up. You have to be ready for them, and you don't want to have to be reinventing the wheel to do so. You need to be able to report on what's going on. You need to be able to get the benefits of a data store, all the things we talked about earlier, aggregation, charts, now in downloadable public beta, BI connector in Excel, all of those capabilities, you want to be able to understand about a global customer base that's in one cluster, one connection string, one set of queries you can run. No ETL, no moving that to some data warehouse over on the side and consolidating a bunch of stuff. It's just online and it's right there in your cluster. That's what meaningful reach is all about. Operational data layer. 100 milliseconds, we all know this figure that 100 milliseconds is basically how we atrophy users. 1% drop in sales from Amazon's testing, and Walmart confirmed it. And basically, your customers don't like you if you have to wait 100 milliseconds or more. It's not fun. And if you hide this, which you can certainly do, then you give up other things, whether it's consistency benefits. You just have to take shortcuts. And that's what most of us have done. But fundamentally, you don't have to give up all those things anymore. If you lose the chance to reach that user in that new market, and they just wrote you off, you've lost the growth opportunity to find market fit there, to understand from that user, to get their feedback, to learn that a little bit of tweaking, and maybe you can nail it in that market. You can't afford to have them bail before they've even engaged. So writes from US East to US East, 2 milliseconds. Obviously, that makes sense in region. To Frankfurt, just under 100 milliseconds. To Singapore, over 200. So, you know, for the first, I think most of us today, because we're primarily thinking about customers in US East and Europe, so that's where the world is today. As a result, we kind of say, good enough. We cut that corner. But as Asia's economy is rising, it's not going to cut it anymore. And plus, the European or US customers, depending on where your cluster is, they will benefit from having a better experience, and so will your business. So let's talk about the options. You can do global multi-region replication. Gives you the single connection string. Gives you low latency reads anywhere you want them. Gives you cross-region high availability. If you lose a region, as long as you're spread across 3 or more regions with Atlas, with standard MongoDB high availability, if you lose a region and you have 3 or more, you will have majority quorum and continuous reads and writes. As long as your application tier is, of course, built to be highly available as well, which hopefully it is. You have to make sure you do that. This is really good for reference data. Like if I want to have the same data everywhere, like maybe just my standard user login collection, people can log in from anywhere, maybe I want to have that everywhere. But fundamentally, the writes are all going to have to go to one place. Just the nature of a MongoDB replica set, right? Or a sharded cluster that out of the gate has one preferred write region, which is how Atlas has been until today. Low latency reads do require that secondary read concern. That's not the end of the world. You could even potentially consider, with a single MongoDB cluster, you could, for example, change the region that is your preferred region even throughout the day. You could do it so that the majority of the users in the world, when they're awake, you have that part of the world taking writes. You can do cool stuff like that. But it's operationally, you have to set all that up. It's not trivial. You can also do cluster per region, and this is a pretty reasonable approach. Has a lot of advantages from a simplicity perspective. You can just have the same app infrastructure in each region, ensure your load balancers appropriately map them correctly, and basically you have your whole stack in each place. Main downsides here, you can't do global aggregation, so you have to basically combine views from multiple places or ETL them out. And yeah, the app tier has to think about knowing which connection string to use where. That's not, it just means you're kind of deploying apps that are a little bit more like pets attached to their database rather than an app tier that can just be symmetrically deployed everywhere. The independent scalability is a nice advantage that I jumped over. I mean, simply having a cluster in each region does have a really nice advantage, which is that if US East is bigger, just make that a bigger cluster, and you can do that in Atlas very easily today. So this might be a good place to start for a lot of folks right now. The thing I demoed earlier, global clusters, Not for everyone necessarily. It depends on what you're trying to achieve. Stole my own thunder earlier, but you can indeed get the best of both worlds and have those sub 10 millisecond writes and updates in multiple regions. You can imagine the way we'll do that is through the global clusters with global writes that we demonstrated earlier in the keynote. The app servers for this will have to be deployed, of course, in every region with our cluster zones. That's critical. Otherwise, if a user in Asia has to write through an app instance in the Americas, which then goes and does a write in Singapore, then you're doing a cross-country round trip. No advantage there, or no significant advantage there. Although some people might shortcut that as sort of a way to keep their data close to their users, maybe. I wouldn't recommend that approach. The ability to scale into regions over time is key. Look, everyone here is going to, I said earlier in the talk, people are going to start with the 3 regions. Let's be honest, most of us will probably start with just US East and Europe. Let's be realistic. But you can introduce Singapore when you're ready, and then you can introduce Mumbai and all the other regions later on. And that's huge with those global clusters. It really is, I don't know if folks in the room are familiar. Actually, quick question. Who in the room has used a sharded cluster with MongoDB? Okay. So the back end of how sharding works is the shard balancer gracefully moves data. Some of you who shell-shocked with MongoDB's earlier versions, you're thinking gracefully, it's gotten a lot better over the years. With Wired Tagger, it's a lot better. The balancer will gracefully move the data between the shards to map to what the metadata in the config servers says they should be mapped to. This is how we can simply introduce a new region, like Mumbai I demonstrated earlier. And literally on the back end, we're going to update the metadata in those config servers. We're going to, of course, remap all those country codes to that, let's say, Mumbai region, like in the example earlier. And then the balancer is going to take care of all the rest of the work. Background process, the balancer intentionally aims to not lock up the cluster or anything like that. It aims to be graceful. And then once it's fully balanced, all the data will be in Mumbai in that example. We've already seen this morning, but it is a beautiful map. Let's talk about how this works a little bit more. I don't know if, I think it's kind of easy to miss it this morning because it sounds like magic at first. Literally, you just put the 2-letter country code in the location field in the document. And then that document will automatically go to the right zone. The hard thing about this, if there is a hard thing about it, is knowing what country code to put in the document. And that's something you have to figure out at the app tier. Maybe you're asking the end user what country they're in. Maybe you figure it out from their metadata. But somehow you need to get that data into the documents. Otherwise, this doesn't make sense. It doesn't work. So that's key. But once you've done so, that DE, it's already mapped in the config metadata on the back end to that Frankfurt region. So you can use country codes, but for the bigger regions like the US, you can use the states as well. That allows you to do US East, US West. And that concept doesn't sound that important today. I mean, some of us do think about US East versus US West and want to have clusters that deliver better latencies there. But over time, these requirements are only going to rise. And over time, there's only going to be more cloud regions, right? This is just the beginning. Google obviously has announced an incredible array just coming this year with Finland online last week and with numerous other interesting regions coming soon. And they're just going to be racing each other, the big 3. To introduce more regions, we're going to be able to reach them all. To define the global collections. The way you're going to query on these, and this is key as well, you need to include that location attribute along with user ID or whatever you've defined as that second attribute in the shard key. If you don't include the location attribute, you'll do a scatter-gather. That can be okay for some of the time, but if you want to do a targeted query that's going to hit the right shard, the right zone, you're going to need to include or be aware at query time, for finds, of course, updates as well, of what that location field should be. You can sort of see how, well, I don't know if you're going back to this. For folks who are not aware, One of the other sort of challenges here, drawbacks to be aware of, is MongoDB shard key is immutable, cannot be changed today. So this means that you need to be comfortable with Johannes's document always being in Germany, tagged DE. And by always, I mean over the next year, because as Elliot said this morning, 4.2, coming next year's release, will enable cross-shard transactions, which will enable change of shard key. So that will make this a lot more interesting, certainly. If Johannes travels to the US next year, once we have those cross-shard transactions, we'll be able to update Johannes' document to US while he's there and update it back to Germany when he leaves. Not there today, so something to be aware of. What that means today is that Johannes, when he travels to the US, his query is still going to go to Germany. That's probably what's happening today anyway, with the single cluster region, so c'est la vie, right? Jumping ahead. Let's look at a little architectural diagram for how you would really build this. Basically, the key here that's kind of a little bit out of scope for the MongoDB layer is, of course, the application layer above MongoDB. You need to have a global load balancer. You need to have a way of ensuring that America's users, for example, will come through an Americas-based application instance, ideally, which in turn can connect directly to the cluster. You want EMEA users to do the same, APAC users to do the same. So you put those application instances all over. Those application instances will in turn, of course, have a MongoDB driver embedded in them. That driver will connect to the connection string we'll give it. And that connection string basically is going to be a list of all the MongoS's. We're going to have MongoS's symmetrically allocated to all of our data nodes. This isn't really a detail you have to worry too much about, but in general in Atlas, we keep MongoS's simply deployed everywhere with all the data nodes, keep it symmetrical and simple. Now, the frankly annoying thing about the old model of connection strings on this is you would have had to have a comma delineated list, he knows, of all your MongoS's in your app connection string. That's kind of ugly, basically. It's like a giant wall of text in your code. The beautiful thing is, I demonstrated earlier, with MongoDB's 3.6 drivers and above, we support those SRV serve records where one concise address maps to all those MongoS's. So your driver, you give it that concise address, it's going to find out, it'll use that address to then find out all the direct MongoS addresses. It's then going to basically ping them all and find out the one that's nearest to it. And that's the one it's going to start doing its direct interaction with. And then from there, that MongoS will route it to the zone. And of course, if it's a zone-targeted query, it'll route it to the local zone. Any questions on this?
The MongoS has to be the same location really with clustering.
Well, the MongoS's are everywhere, but for the latency to be optimized, you would want the MongoS to be in the same zone. Because otherwise, so it's not, good question. In other words, it isn't just user, app, MongoS, data. It isn't just that the user and the app needs to be in the same region. It all needs to be lined up. Otherwise, there's going to be a zigzagging hop there somewhere.
So the underlying data is flowing across the clusters. But other than the other application layer related to MongoS is independent and silent for that cluster.
Well, so there's MongoS's that's actually going across for the whole cluster. All of them can be reached by all drivers, generally speaking. And for example, if a driver,
so EMEA users can connect to the US Eastern Zone MongoS.
Generally they can, but the trick is that the driver generally won't. The driver's going to say that one's further away. It's going to just ping and find the nearest MongoS. So you don't have to worry about this. In general, the driver will find the nearest MongoS and then execute queries through that. Yeah. I missed it. Write anywhere, read anywhere. Yep. Yeah, great question. It's probably going to come up later, but I'll just talk about it now. I mean, what we're looking at here is a simplified view in that the east zone has the replicas here, but there's that button in Atlas, but you don't have to do it through the button. You can do it, you could have certain zones replicate certain. Basically, you could have a replica from any of these zones in any other zone in a couple clicks in Atlas. By the way, everything in Atlas can be driven through REST APIs as well, if you don't know.
The problem
Yeah. Yes. So, yep. Yeah, great question. So one of the cool things about this model of, the zones cluster being in the zone is that generally, the read replicas are not going to fall particularly far behind in zone because they're near each other. The gentleman's worried about the case where we have replicas in the other zones, and they're going to fall behind due to network latency issues, and that's where it is a concern to think about. Ultimately, it's not an easy one to there's no magic solution for it. And of course, it depends on basically the internet congestion at the time and the particular regions and the connectivity. But fundamentally, you can architect your application in such a way, for example, to consider using write concerns or read concerns or essentially other paradigms, or you can be comfortable perhaps not having up-to-date reads in those other regions. So I would say that's an area that requires fine optimization, and it is probably one of the most complex areas to reason about in this whole thing.
So you are using any kind of special protocol to
Nothing more special than, of course, end-to-end TLS and compression over the wire. So encryption and compression over the wire, but otherwise, just MongoDB. So you'll probably find, for example, I haven't tested. We haven't done all the benchmarking and published all the blogs on this yet, but I would imagine that a cross-region cluster on Google, for example, probably depends on the network links in these particular regions. Google's global network generally is one of their strong suits, so it might be something where you'll find some better performance than AWS, for example. It probably all depends. So stay tuned for more information on this front. It's a great question.
So how the ops manager should be configured?
Ops manager? Well, you mean MongoDB Ops Manager? Yeah. So, I mean, what we're talking about here is something that you can do in Atlas in a couple clicks. If you wanted to do this in Ops Manager,
No, that's not what
yeah,
and you have this in the Atlas.
yeah.
In the cloud. So how your ops manager should be configured? So can I have a centralized ops manager managing the entire cluster?
I see what you're saying. Yeah, so let me take a step back. For folks in the room who are not as familiar, MongoDB Atlas and Ops Manager. Ops Manager is our on-prem sort of management as a service software package that you can run in your own data center, private cloud. But Ops Manager is sibling code base to Atlas. So essentially, we fork the Atlas code base, we remove the infrastructure management pieces, make it pure software, and deliver that as Ops Manager. And as a result, Atlas has in it anything that you're used to seeing in Ops Manager. Some of the abstractions are one layer up. So all the same monitoring alerts, backups, anything you have in Ops Manager, Atlas also has. You don't have some levels of control. Like in Ops Manager, you could choose to, do something at the node level that Atlas will kind of abstract away and have it be more of a cluster level configuration. Atlas obviously is a fundamentally different experience because you can declaratively get the cluster endpoint just on demand. Ops Manager, you run the backend infrastructure. To make this possible, you'd have to spin up whether it's an EC2 instance or you could do this with your own data centers with geo-zone sharding. You have to get the infrastructure in place. You have to install the agents for Ops Manager on that infrastructure. You then get all those agents to call home to your Ops Manager, and then you instrument them to deploy the cluster. So it's doable yourself, but frankly, we've had this. One of the reasons we built this into Atlas is that we had this geo-zone capability in Ops Manager in a you can do it sense for a couple of years now. And to be honest with you, almost none of our customers got there. There's just too much heavy lifting. Even just managing their own environments in 1, 2, 3 data centers is a big project typically. Whereas in Atlas, we can just fundamentally change it and deliver this capability and show what can be done. And so I think we're going to see the critical mass of this will be in Atlas.
So continuity, backups, monitoring,
Yeah.
and these are relevant.
Everything's in Atlas, absolutely. Config DBs are, they're not shown here, but of course the config DBs themselves are highly available and replicated across the zones. So great question. Can Atlas run in the private cloud like with Kubernetes? Ultimately, it's not Atlas. I mean, what James demoed earlier, which is Ops Manager in beta on Kubernetes, it's not Atlas in that you're still running the Kubernetes cluster yourself and you're sort of using, you're instrumenting all of the layers, whether it's, You have to, you're configuring everything. Infrastructure, Kubernetes, network, security, upgrades. You still do it all yourself, but with that Kubernetes layer, you get some of the automation capabilities. You get to standardize if that's what you're doing in your data center. In the public cloud, like once you start shifting to public cloud, frankly, if you're using Kubernetes for database management in the public cloud, I would argue you're probably making a mistake. Might as well go there. If you're using Kubernetes for database management in the public cloud, the risk is you're treating public cloud the way you've treated your on-prem data center. But really, you get all the benefits of cloud if you can, for all of the hard-to-manage pieces, move them to as a service. And then use Kubernetes for your application tier, which is the part that it was really built for originally, in public cloud. But on-prem, if you're standardizing on Kubernetes, and you need to run MongoDB in that paradigm, that's where Ops Manager comes in. So Kubernetes, in public cloud, Kubernetes for app tier, connect to Atlas is a perfect match. You can deploy an Atlas cluster through an API call in a couple minutes. I already jumped to the connection string, but it really is that concise, which is beautiful from a developer experience perspective. Yeah, so global reads, we already talked about this, jumping ahead. But all of this, not only can you enable those global reads, but the thing I showed at the very beginning of my demo, the ability to introduce read replica regions for high availability or for low latency reads, you can configure all of that in a global cluster in Atlas at the zone level. So you could decide, you know what, I want to have those 3 zones, but in the US specifically, I want to have read replicas in US West. And you don't have to worry about doing that in the other 2 zones, whether it's Frankfurt or Singapore or whatever. All of it is configurable at the zone level, the replication configuration. And you can decide actually when you're introducing read replica regions into a particular zone there, you can decide whether those regions participate in elections or instead are purely read-only but don't participate in elections. The advantage of not having nodes participate in elections is it doesn't slow elections down. You want elections to be really fast for failover. So if you have read replicas, for example, in a zone on the other side of the world, just note you don't have to have them be part of the election process. Limits and where this is all going. So high-level stats, not sure exactly how accurate this is at this point. We have in-country regions for about 27% of the world's population on Atlas today. It's not good enough, right? We need to be higher than 27. It's not terrible because a lot of these countries are directly neighboring or very near a region, right? I mean, you got Poland right there next to Germany. We're not in Poland yet because none of the big 3 are yet, but pretty good for Poland today. Still, 27 is not good enough. 54 global regions, 15 on AWS across 38 availability zones. Azure, has 26 regions. For those who are not familiar, the 3 use some slightly different nomenclature. Azure didn't really have this paradigm of availability zones until their new Paris region, France region. So Azure's regions were really, they give you a building block called a fault domain rather than a availability zone, whereas AWS and Google give you availability zones, which are fundamentally different data centers in the region. So on Azure, in a sense, your in-region availability, it's really more rack level than data center level. But because we have cross-region on Azure, if you want to be across 3 true Azure regions, that's no problem.
What about specific regions in China?
Great question. I'll get there in a second. Yeah. So yeah, the cloud providers are expanding fast, but there are some serious gaps. Africa broadly is a gap, big time. South Africa has been announced by Azure, so that'll be exciting when we see that. Biggest economies in Africa, FYI, Nigeria, South Africa, and Egypt. Ethiopia is the fastest growing economy in Europe. They're damming the Nile. So we're going to see more and more action across Africa. I bet we'll see a region, in the next 10 years, somewhere north of South Africa. Middle East, there's been announcements, so we'll see. The question is, in my mind anyway, are they going to be true regular public cloud regions, or are they going to be special? Because there are these special regions that exist. China is very complex. I'm sure everyone, actually, quick show of hands, anyone in the room have data in China today? And are you running it in one of the, like AWS China through that third party?
We were on
VNet?
But they didn't like it.
Okay.
So now we're looking at outlet.
Interesting. Understood. Anyone else in China? How are you doing it?
We were in Hacnet in China at my last place, and the paperwork to get through the process of even provisioning a server was nuts.
Yeah, it's challenging. What about someone over here? Azure? VNet. They're local. Yeah, so in China, you know, these independent entities in China are running sort of like an Azure stack locally, VNet. There's equivalent for that for AWS. By far the cloud leader in China is AliCloud, and they do have a footprint outside of China now as well. I don't know yet how we're going to get Atlas into China, but we need to make that experience possible. Russia's also complex. There isn't really a cloud leader there yet at all. Yandex isn't in the game. VK's not in the game. Frankfurt's pretty good from a latency perspective. Finland just launched on Google, great latency, but again, Russia's got complex regulations, so it's to be determined whether that's going to cut it. And then government, like GovCloud, there's special regions we just can't reach yet. Luckily, MongoDB can run everywhere. You got to use Ops Manager in some places. That's okay. We use Atlas where we can, and over time there'll be more and more places we can in Atlas. We can live migrate into Atlas when we need to, when that's ready. In the interim, we have a way to run this database everywhere, and it's the same exact application experience from a developer perspective. That's one of the key things about MongoDB. Thinking ahead to 2030, I think it's just kind of interesting, not the best slide, but this is a 2030 projection of GDP from, I forget who did the analysis, but the arrows kind of indicate just the relative acceleration compared to where we are in the GDP stack rank today. So if you look at the top 10 countries by 2030 by GDP, you know, I challenge you all to think about how much of your business is happening in those countries, because by 2030, if you're not there, then you're not going to be acceptable to your boardroom. So world's changing very fast. Some countries on this list that we don't even think about at all. Some that we all are trying to think about, like definitely China. But yeah, so exciting time. You can go incrementally. You know, you can stay in a single region like many of us are today. You can go multi-region HA, read replica regions, introduce those over time, get used to running an application in multiple regions, get used to a highly available app tier. Then you can grow from there. You can enable those global rights we saw with global clusters when you're ready to do that, or mix and match Atlas with Ops Manager, et cetera. So this is a journey that's going to be fluid over time. You don't have to figure it all out and be everywhere immediately on day one. You find traction where you need it, where you can find it, and double down there. That's what this is all about. This one?
The next one.
This one? Ah, it's forward?
Yeah.
Back one, or? Sorry.
Yeah, the location attribute to your data. So
Yeah.
it's a change that can be done, integrated on your application, so that whenever you add a cluster, you will need to change your application.
Good question. Ultimately, no. So you need to, fundamentally, you're going to have to introduce this concept of thinking about the location. You can do that later, of course, but you need to be able to give the document a location value, and you need to be able to, therefore, figure out what the appropriate value should be.
But why my application should be dependent on the location from the user perspective?
Well, because we're trying, I mean, conceptually, we're trying to give the user an experience that's specific to them.
True, but
Yeah.
that user may reside anywhere in the world, and
Yes, good point.
that function should be transparent to the user interface. Right?
Yes, agree with you completely. So yeah, it's a great point. In other words, it'd be cool to imagine, and I think Stitch will probably eventually get us there, that essentially the app tier layer that determines the country code, if you will, be something that you can just get from metadata, like in that SDK for a mobile user, and it just essentially can automatically. So those things will come. But right now, you know.
You do the geocoding and then just
Yeah, that's exactly. And you can do that in the app today, but making it easier, absolutely. We need to do that. Great point. you can follow your users, you can move your clusters around. To be honest with you, we've had an Atlas customer. They migrated from AWS to Google Cloud in US West, and then they moved from Google Cloud in US West to Taiwan because their users over time just fundamentally the center of gravity moved to Asia, and they're able to do that all in Atlas. So go out and reach those 4 billion plus internet users, or a small subset of them with that workflow processing application that I'm building. It's still cool if it's global. That's it, folks. Any other questions or comments on what we've seen today? Yeah.
Do you see over the next 5 to 10 years more US-based dilemmas than just US?
Oh, absolutely. There's already across the big 3 clouds, there's a ton of US regions already. Google's got South Carolina, Iowa, Azure's got 2 in the west, 2 in the east, and a couple in the center. And so when you start thinking about the combination of all 3, there's tons and tons of regions coming online. It's going to be more and more, and we're going to expect latencies to drop over time as a result. So thanks, guys. We're out of time. Sorry. Yeah.
Give it up for Andrew. Thanks, Andrew.
Thanks, man.